Yeah.
Perhaps very general. I'm a physicist. I liked very much the presentation of Koen van Mechelen, but I have a question for the other two colleagues at the desk. I heard the word rejuvenation. I see you have tools, insights to go to designing, making new material. What about just a philosophical question? Is this a road towards immortality?
Well, in this project we have a physicist in the last project, because obviously what I dream is at the end of the day, if you have this growing growth plate in vitro, you have essentially an engine that keeps steering the system. And this French physicist tells me that there's a chance that one day he might transfer that into one single formula, evaluating the entropy and ectropy of the system. So I invite him to join us on a regular basis and keep following us, and I hope that one day he might actually come up with this. But I would say the gap is still large, but we start to talk to each other because we have to develop a common language. It took me 10 years to be able to understand an engineer, and I still don't understand it very well. I'd like to invite you to come to my office, because every week there is like a fight going on between the engineers and the biologists. Bringing in a physicist there is yet another dimension in which, so as well, the engineers and the biologists don't understand anything anymore.
I advise you to bring in an artist.
Yeah.
Yeah, since you're dealing with growth, energy is of course at the base of growth. So I was wondering, are you looking then also at the functioning of the mitochondria, the power centers of our bodies?
Well, yeah, for sure. Associated with all this, we are trying to go deeper into what drives the engine, obviously. But first we need to get the system going robustly, and that is still the ongoing research. We need to be able to monitor the different layers, and it's only when I'm feeling comfortable that this system is running independently and autonomously to some extent, then we are going to start looking into these aspects of it. So it's not only for tissue repair, tissue regeneration. Potentially you have a system there that is allowing them to look more deeply into what drives the system and the energy behind all this. Yeah.
How can it be that so-called lower animal species outsmart us? Because if you have a reptile and you cut off his tail, he spontaneously regenerates already its tail, while we have to do that many efforts to do some regeneration.
I guess it's a very good question where we don't really have an answer for. So in these reptiles, indeed, you have the same mechanism that I showed you. If you take a cell and you put 4 pieces of genetic material in it, it de-differentiates to a stem cell and then it can come back. So in these reptiles, at the end of the wound, at the wound surface, is actually a spontaneous de-differentiation and re-differentiation, so it can grow back. Why has it disappeared in higher species? If I had to guess, because it's probably somehow dangerous for longer living, or for highest, the process is dangerous because it's also the process that occurs if you develop cancer, where some process of de-differentiation happens. And so, I don't think anybody knows why it disappeared between, reptile and us, but that's my guess.
It's also only partially true that it has disappeared, because you know about fetal surgery. There was still an article in the newspaper. In fetal surgery, and you see this very well in children with a split mandible and split maxilla, that when they go in and they do the surgery in the fetus, that after birth it's not only completely repaired, you don't see anything anymore. There's zero scarring. So the true regeneration in human being has not disappeared. The only thing is that the postnatal tissue regeneration has dramatically reduced. Although we have examples of small children, and I had one X-ray laying of one of child that basically recovered the top of the tip quite well at the age of 2 years old. So I do have examples of human limb regeneration, you could call this, that we see in the axolotl in the human being. The bad news is, as we get older, although we still have some stem cells around, it looks like we've lost the magic ones. And the reason for that is, I'm not sure. The artist may have.
To come back to the sort of the larger team in what we were discussing in the afternoon, I see some kind of a paradigm difference between the two biomedical talks that we had and basically the talk from Rini van Est. If we really go into designing human life, that's something different than what the two biomedical people did, which is basically therapy, healing people who have disease. Where, while designing human life, in my opinion, is more like improving human life and has nothing to do with disease. Is there a different paradigm between the two groups here? Really?
Well, the reason I stressed in my talk actually the digital modification of life is that for the last 30 years we had the bio debate, you know, and bioethics is all about biotechnology up till now. But I think because we have this convergence, and also because we have this experience with, you know, the rise of the internet and the influence of information technology, I think that the whole way, I mean, human behavior, social interaction, communication, the way we organize ourselves, the way we behave, it's so strongly influenced by information technology that, well, we as a Rathenow Institute, we want to bring in this notion of digital modification of, well, social experience. Because I think this is a major, you could say, black spot in our discussion. You see, so we are already, for the last 20 years or 30 years, we have changed human life, human experience in a gigantic way. I think if you would compare it with biotech, I think information technology has been far more influential in changing our lives than biotech, because biotech is a lot about, you know, this discussion about living life forever. I mean, we're discussing about that for 30 years, but we are changing the world under our feet, and we're not talking about that. You see, we're talking about problems and challenges far away in 20 or 30 years, but what is actually happening now, nobody discusses it. You know, that's actually why I wanted to give this example. Because in this project, Making Perfect Life, we look at the both sides, biotech side, and also, well, more the digitalization side.
But does it then mean that designing human life will actually be sort of like a redesigned brain and all the new types of communications that we do, and not a biomedical redesigned human life?
I think if you look at information technology, you see that the way we design human life, or the efforts we take to control human life, it's not going anywhere. You see, it's happening to us, and there are major players. I mean, we're talking about businesses. You see, if you talk about the game industry, it's an $80 billion business. You see, and nobody's talking about that. We're just playing. You know, and we don't know how this. Well, I'm intrigued about this notion of who is making the code. I mean, biotechnology is about decoding life, but we are also decoding our social behavior. And there are engineers at the other side that are making the software, and we don't talk about it. We're not aware about it. We are not aware about the ways we are being influenced, and we don't have a discussion. You see, so the way we design human life, it's not being discussed. That would be my statement.
I think it is being discussed, but probably in other settings. I mean, the impact of online networks and multiplayer online games, etc. This is being discussed in very different settings, and I totally agree with you that these are the current things that are already in place that have a huge impact on how we organize our own life and how our life is lived. But I do think that also within the evolutions of bioscience and technologies, there's going to be a moment in which this is, but not in terms of the concrete impact on our lives. But it's going to be also an $80 billion business, but with a very concrete impact on human life. And I think it's super important to, at this point, start the debate. Do we want the equivalent of a massive online player game with that equivalent of impact on our life, but then in another domain, if you understand what I'm saying?
Yes.
And in that sense, I do think that all the speakers more or less relate, because we've been talking about growing organs, growing bones, growing, cross-breeding chickens, and then I think what the common factor in that is, to get back to your questions, what don't we want to lose? Because if you can grow bones and this becomes a business, maybe I'm not happy with the leg I have and I could want like 2 stronger legs and make them run faster, and I have the money to pay for it. You know, I can enhance myself, and we get into this situation where we at that point have the demand and supply, where we have the supply, and then you start to think about the demand. I think it's more interesting to start to think about the demand right now.
I was very intrigued by the remark Koen made, that maybe the chicken, I mean, he can only go up to 50 meters, and maybe that's the best thing. That's what you said. And it's the same with this question. Okay, will it give us eternal life? Well, but maybe that's not the best thing, you see. Maybe at this moment we're at an average of 80 years or something. Is that the best thing? Or should we become 60? Or should... Huh?
We never know. It's a labyrinth, and it's what I tried to say also in my speech. I mean, it's about crossing boundaries, and you don't know how far you can cross and where you can cross it. I mean, what I see, what is the same thing between all these speeches, that is, you know, we started with our domestication, which is one of the most important things in our society. From the moment that you start there, well, everything starts in a kind of labyrinth where we're in, and where we're trying to reconstruct everything. I was very impressed if I saw from Catherine the building. You know, first we are very much inspired by trying to get geometrical forms and putting them together. We did it also with human beings, and you see it also in art. That if you think about the Picasso, he's reshaping human by by making blocks and putting the nose on another side, and this is what we're doing today again. But we're going inside, and we start in, I mean, I will say play with the cells, and then we say, okay, how can we rebuild a human being from that part? And that is what I'm trying to say in my lecture. I mean, it started already there, and by simple handling, and it goes all the way further and further, but you don't know what you do. And well, what is also important, we don't know what we do, but if there is the knowledge, if there is the money, and if the environment is ready, it will be there. This is what it's going to be, and we are looking to that. I mean, the first heart transplantation, everybody was against, but when there is the knowledge and the money, we are so glad it's there. I mean, I would like it.
Professor every morning that you go to the lab, you have the impression, hey, I'm redesigning human life.
Yeah.
Oh, I would not. No, I don't. But I'm redesigning human life, or trying to make something that looks like real life, but we're not trying to redesigning. We try to change it. That's not. We're actually mostly trying to create normal things, and you know, a normal way of producing cell, a normal liver cell. And so the efforts that we actually put forward is to actually make the normal cells, but not a better cell than what is currently present in our body. That it would, redesigning, probably not the word, correct word, designing, maybe.
Professor Luiten, what do you think about the example that Karen gave? If you make a new bone, but she comes for a new leg, while she wants to come for a better leg.
For sure, potentially it will be possible. When you read in China, they are lengthening their bones because then when they are 170, they can get into positions. We have a robust engineering process. We can fix this in 3 weeks, potentially. Yeah. So we are redesigning life, but I'm a clinician, which means I don't think of these applications. I see 2 days a week patients, two days a week patients. And I see that we are very limited in restoring damaged tissues. In rheumatology, we are excellent in stopping inflammation and reducing pain. But when I want to have my patient back on his feet and have the same quality of life as previously, we are very poor in the repair of normal function. And this is why regenerative medicine for me is my attention. But by creating such systems, obviously the applications could be far beyond that. But that's the same with Catherine, the day she comes up with hematopoietic stem cells. Well, maybe it's already today that top sporters are infusing them on a regular basis every day after the Tour de France and so on. So these are implications that we don't really think of every day.
And whose responsibility would that be to think of that?
Well, that's a good question. Good question. Well, this is why I'm here at the symposium also, because I thought the symposium was actually, like most actions in Limburg, are pretty innovative.
Now I have a question for the lady. Yeah.
Well, I came here because I thought it would be very interesting to know more about human life and designing human life. But before you can design human life, you have to know what it is or what the concept means. And I think I heard very different conceptions of human life here. So I'm just interested in really that people would tell me what they mean when they talk about human life. When is it human? And when do you speak of life? Because Mr. Van Est said was a very different conception of human life than what I heard from the other speakers. That's all I want to say.
Okay, Vinny, you're the first challenge to take up the challenge.
Yes, first of all, I was pleasantly surprised with the notion of human life beginning in the brain. But human life, that's a social concept. And for me, I'm from the Rathenau Institute, which is a parliamentary technology assessment. For me, designing human life is a political question. So I want to raise conscience within the public, within the Dutch Parliament, within the European Parliament. So, I mean, life is what we make it, you see, and that's a struggle. So, I mean, I'm very much fond of this playful way of how we design life. We're in the process of shaping life, but at the same time, it's a power struggle, you see, and it's a struggle on definitions. So, what kinds of ideas get funded, for example? You see, well, let me give an example. My father had Alzheimer. Okay, do we put our money in a lot of research and development? I think that's important. But it's also important to give a lot of money towards, taking care of elderly people. You see, so there's always a balance. So for me, it's a political debate. It's a public debate. And I think in Belgium you have a beautiful public debate.
About that.
But unfortunately, I love not where to put our money, or whether we have to make the choice between research and to take care of elderly. Professor Leijten, you want to react to?
I'm looking at life from the medical standpoint, obviously. And so, and therefore that means restoring normal function. And I would strongly argue not argue because I know you are following this, but in medicine we have dramatically changed. We do more personalized medicine, we do disease management, and so we are coupling new treatments to proper patient refunctionalization also in the society and so on. So there is already substantial attention in the medical world, at least in some parts of the medical world, in making sure that the patient is getting back into its normal function again, so he can interact again with the environment and be happy and have a high self-esteem, which is very important. So for me as a musculoskeletal expert, is restoring self-esteem and self-maintenance, so you can basically be independent from the others, is for me restoring human life. But that's obviously within that tunnel view. Obviously, with some of the technology you are developing, we could make potentially in a number of years a person with a third leg, or a person with an additional joint in the shoulder. Potentially this could be happening. And then I'm not talking about Mr. Art from this morning, who is making with his chickens all kinds of strange things by genetic engineering and genetic manipulation. But that goes what I call beyond physiological and normal functioning. And that is another debate. And that's an ethical debate. Because for me, ethics means that we are respecting what nature has selected for us over 100 millions of years. And that's what we as medics are trying to restore and maintain.
Are we going to do that forever? Until what age?
That's a good question. That's a good question. Despite the fact that in medicine we get a lot of criticism that we come up with many new medications and don't do much for our patients, the average survival of the patient has increased from 72 years when I started my medical studies to over 80 years in 25 years time. So extending human life with 12, 13 years is certainly possible, and we will go beyond that. The estimations now are that probably 120 years old is going to be the barrier we can reach, and so there is a change in focus in medicine where we increasingly pay attention to life quality management and these aspects rather than starting to further extend life. Obviously, when stem cell technology is getting deeper and deeper in our setting, potentially we may start rejuvenating pools of cells in the body which are disappearing with age, which can bring tissue maintenance and turnover on a level which is much better than we have now. So there is potentially a limit if you are really thinking beyond the barriers. I think yes, potentially we can become immortal because the stem cell in vitro can go through many iterations and it never stops.
I just want to comment on this notion that we as physicians just repair human beings. I think there's also an inbuilt error in there because, especially in my field, when we talk about repairing the brain and the nervous system in general, it's very difficult to say what is the normal situation. So if we repair the brain, do we go back, if we rejuvenate the brain, if we go back, okay, we want the brain we had exactly 1 minute before the accident, or do we go back 10 years because then the brain was much fresher, or do we go back to puberty? I wouldn't, but yeah. So it's very, very difficult to define what is really repairing, because in the moment we have some possibilities there, and we can, for example, improve the memory functions and the self-esteem of Alzheimer patients. We are going back a little bit in time, but it's also a new social situation, so we are creating really human life already. And all these students who are taking neuro-enhancing drugs, so Ritalin and all these drugs which are considered as drugs for the ill, which are already used in the universities, yeah? Or the students who take some, I don't say the name, but take some drugs to reduce their stress before the exams. I mean, we see this already, it's there. I don't know how many students take drugs before the exams, but some of them are really cool. Yeah? So, okay.
I guess that's from experience.